Since its launch in late 2021, the James Webb Space Telescope has completely transformed our understanding of the universe. It was designed to extend our reach into the cosmos, to see farther and with more clarity than any instrument before it. But now something has changed. The most powerful telescope humanity has ever built has just captured something so extraordinary, so unexplainable that leading scientists are calling it a crisis in physics. These are not just remarkable discoveries, they're unsettling. From impossible galaxies to signs of life beyond Earth, Webb's latest findings have shattered the limits of known science. What if everything we thought we understood about the birth of the universe was wrong? That question now echoes through research labs and universities across the world, because what you're about to discover may change the way you look at the night sky forever. It all began with a whisper from the cosmos. Faint signals arrived, light from galaxies that defied all conventional understanding. In July 2023, a team of astrophysicists analyzing deep field data from Webb identified 3 peculiar galaxies. They were like nothing ever observed before. The light they emitted didn't match typical patterns of star formation. Instead, it hinted at something entirely new: dark stars. Dark stars are theoretical objects not powered by nuclear fusion like ordinary stars, but by dark matter itself. These colossal entities could have formed in the early universe, growing to unimaginable sizes. Some scientists now believe they might be the missing puzzle piece in explaining the abundance of black holes scattered across the cosmos. And that's where it gets chilling. Dark matter makes up 85% of the universe, and yet we still don't truly understand what it is. If dark stars are real, then everything we know about stellar evolution could be wrong. But the James Webb Space Telescope wasn't finished yet. It was just beginning. The telescope next turned its gaze toward a distant exoplanet named GJ-1214b, a super-Earth orbiting a red dwarf star about 40 light-years away. Initially, this world was dismissed. Too hot, too cloud-covered for study. But Webb's infrared instruments were able to pierce through the thick atmosphere, and what they found stunned researchers. Not only did GJ-1214b have enormous clouds of water vapor, but parts of its atmosphere appeared to be surprisingly habitable. Even more astonishing was the presence of methane, a compound often linked to biological activity. Some scientists now propose that GJ-1214b could be a water world entirely covered in vast global oceans. How could life exist in such an alien environment? We might be closer to that answer than ever before, because Webb is now revealing worlds that mirror our own, not just in temperature and atmospheric composition, but possibly in their capacity for life. We typically associate smoke with Earth, fires, industry, combustion. But what if the universe had been sending signals for billions of years? In one of its more mind-bending observations, Webb detected polycyclic aromatic hydrocarbons, organic, molecules found in smoke, and also critical to the chemistry of life. These molecules were observed in a galaxy over 12 billion light-years away. That means their light has traveled since near the dawn of time. Webb was able to detect them thanks to a cosmic phenomenon known as gravitational lensing, which magnifies distant light sources. The implications are staggering. If complex carbon molecules existed that long ago before Earth even formed, then life may not just be possible throughout the universe. It might be inevitable, and yet even this is only scratching the surface of what Webb has uncovered. One of Webb's most incredible achievements came when it recreated what once took the Hubble telescope 11 days to observe in under 24 hours. But what it revealed wasn't just breathtaking. It was deeply unsettling. In its ultra-deep field images, Webb found galaxies so old, so massive and well-formed that they should not exist. These galaxies appeared less than 600 million years after the Big Bang, but were already mature, dense and filled with supermassive black holes, some of which are 1,000 times more massive than the one in the center of the Milky Way. According to our models, such complexity takes billions of years to develop. Joel Lear, an astronomer from Penn State, described these findings as the most puzzling and intriguing collection of objects he'd seen in his career. If our models can't explain these ancient giants, perhaps we've misunderstood the universe's beginning entirely. Among the countless images Webb has produced, there's one that sent a chill through the scientific community. It's a nearly symmetrical, spiral galaxy, so perfectly shaped and colored, it appears artificial. But what truly shocked researchers wasn't the galaxy's form, it was the unexpected duplication of its spectral signature. Webb had captured what looked like a mirror version of the same galaxy, slightly displaced in time and space. While gravitational lensing can distort images, this case was different. Both versions showed synchronized energy fluctuations, identical redshifts and matching star cluster movements, as if the galaxy existed in two places at once. Some theorists now wonder, could this be evidence of a multiverse? Could overlapping realities be stitched into the very fabric of space-time, only now visible through Webb's precision? If so, the telescope may not just be a window into the past, but into parallel versions of our own existence. While Webb is focused on the infrared spectrum, its instruments can also detect subtle frequency vibrations, essentially the signal signatures of space. In early 2024, while monitoring a dying star in the Carina Nebula, Webb picked up a rhythmic low-frequency pattern unlike anything ever recorded. When translated into data, the pattern resembled a pulse, repeating, steady, and disturbingly precise. Instead of the chaotic activity typically produced by a collapsing star, this pattern felt ordered. Some likened it to a heartbeat. Others described it as a coded signal. The star entering its death throes seemed to be sending a final transmission as it collapsed into a black hole. Whether this is a natural cosmic rhythm or something more deliberate remains uncertain. The amount of data Webb generates is far beyond what humans can process alone. That's why, for the first time, NASA employed a machine learning model designed to interpret Webb's raw telemetry. The AI was trained to recognize known cosmic patterns, but it did much more. After several days of quiet analysis, the AI flagged a region of space not once, but 3 times. This region was a void devoid of stars, galaxies, or even dust. But within it, the AI detected an oscillating gravitational pattern. When visualized, it formed a spiral, not of matter, but of gravitational distortion. The same pattern had briefly appeared in old Hubble data, where it had been dismissed as noise, but now Webb had confirmed it. Whatever it is, it moves, it pulses, and it bends space around it like a lens. The AI refused to classify it, assigning it a single label, unknown entity. And then came perhaps the most mind-blowing revelation of all. While mapping galaxies near the constellation Fornax, astronomers noticed something strange, a temporal distortion. Redshift data from galaxies in the same region appeared to move backward in time. That's not just odd, it's impossible. Redshift is supposed to increase with distance, marking older light. But here, the farther the galaxy, the younger the light appeared. This suggested a break in the linear flow of time itself. Some call it a time fold, like a crease in space-time where events get replayed out of order. Others believe it could be evidence of a simulation glitch, a crack in whichever framework governs reality. One thing is certain, Webb may have proven that time is not as stable or consistent as we once believed. So now we stand on the edge of understanding, staring into a cosmos that no longer plays by the rules we trusted. The James Webb Space Telescope was meant to confirm our theories, to illuminate the origins of everything. Instead, it's torn the very fabric of science apart. From dark stars born in the shadows to galaxies that matured too quickly, from echoes of parallel realities to the eerie pulse of dying suns, Webb isn't just observing the universe, it's redefining it. And as if that weren't enough, artificial intelligence has joined the search, flagging patterns we don't understand, highlighting gravitational ghosts in the void between galaxies. The telescope was built to see farther than ever before, but what it found may be more than we're ready to face. If the past months have shown us anything, it's this. Space is not silent. It's not simple, and it's far from solved. The laws we trusted may be guidelines. The beginning we believed in may be just another checkpoint. And the scariest part, we've only just begun. So what do you think? Has James Webb truly broken science, or has it finally set it free?